All right, hey guys. Today I'm going to start a series of videos reviewing for the AP Computer Science A test. And we're going to go through about 10 modules to cover the content that's in this book, which is the AP Computer Science Prep test book sample test. So you can get that if you would like. But we're going to go through the content in here and prepare for this exam. So I'm going to jump in here and I'm going to just sort of have this here referred just to make sure I cover everything. But in this video today, we're going to be starting in chapter 3. We'll go through just chapter 3 in this video. We're going to skip the first chunk. It's valuable. This is all like tips and tricks on how to take a test well. That's great, but that doesn't have anything to do with computer science, so we're going to just jump into the computer science stuff. All right. So what's computer science? The computer science is basically the practice and the study of programming computers and designing software. It's been around for quite a number of years now, and it's ever more important as computers get more sophisticated and more complex. So what is developing software? It's writing programs, right? And what is a program? It is simply a sequential set of steps that a computer follows. A computer can't do anything else except follow a sequential set of steps. Stand up, take 3 steps forward, turn right, bark like a dog 4 times, sit down. Right? Set of steps. Now, a computer is a piece of hardware, and the chips inside the computer only speak zeros and ones. That's all it knows. And they have parts in the chip that aren't very familiar to most people, things like registers and something called an ALU and a CPU and all these other parts that most people who aren't electrical engineers don't have to deal with. So it's difficult to program that computer directly. You would have to use very low-level commands. For example, adding 2 numbers. You would say adding 2 and 3. You would say take the binary 0 and 1 representation of 2, put it in this register. Take the binary representation of 3, put it in that register. Perform the addition operation on it, take the result, put it in some memory somewhere. Okay, that's really complicated, and human beings don't think that way. So pretty early on in the development of computers, people came up with the idea of a high-level programming language, like Java, which we're going to talk about today. But there's, of course, dozens of others that you've probably heard of. Fortran and COBOL are old ones. Python is a newer one, JavaScript. So we're going to focus on Java for examples here, but a higher-level programming language lets you think of problems in a way that humans normally do. It's not quite like speaking, it's more like math. So it's closer to math. Well, we understand math. We can talk about math. We don't talk zeros and ones very well. So what we have to do, though, is translate the math-like programming in Java to the zeros and ones that the computer actually needs. And that process is called a compiler. A compiler is essentially a translator that translates the Java into zeros and ones. And that happens after you've written the program. You go through a step to compile the program, then you can run the program. Okay. So this material, by the way, is coming from the book, so it will be covered on the AP exam. There is a concept called interpreting, an interpreter. That process of translation is sometimes called interpreting. Now, this is a side note. I don't know if this will be on the exam or not, but there are some languages that are interpreted. It doesn't have a separate step for compiling. It actually changes the language into the zeros and ones as it runs. Okay, and you're like, well, okay, what's the difference? Why is that important? Well, there's pluses and minuses to that. If you compile your program once, it dumps it into binary form and you can run it 1,000,000 times and it's fast. If you do the translation every single time it runs, it'll run slower. So interpreted languages are slower. But a lot of programmers feel that they're easier to code in because you don't have to go through this extra step of compiling. So the right answer, though, after doing this for many, many years, is that each technology has a time and a place where it's best used. There's not one size fits all. So again, today for these examples, we're going to be compiling and we're going to be looking at Java. So before we get into the actual code, though, there's this concept of comments. And commenting is a way of adding information into your code that isn't part of the program. It's just so you can read it. And there's two kinds of comments that Java supports. One is called an inline comment, and it starts with 2 slashes. Okay, 2 slashes and whatever you want to the end of the line. And the compiler will see this and it'll just say, it'll ignore it. It's not gonna do anything, it's just gonna keep going. But somebody reading your code, obviously a human being, would read this. So this should be, human readable text that hopefully tells something important about the code you're writing. Might give a description or a little hint about what you're trying to do. And these inline comments are very handy when you just have a quick thing to say, or maybe it's at the end of a line, you have a line of code over here and you just want to give a little hint as to what you meant. So you put an inline comment at the end. The other kind of comment that Java supports is a multi-line comment. Starts off with a slash and a star, and here's line 1, line 2, ... and then star slash to close it. And this could be a whole block of text, whole bunch of stuff, many lines, dozens of lines, can be huge. And this is where you have a lot of description. Like in the beginning, before a chunk of code, you might want to explain, here's what I'm trying to do here, so that other people can understand you. And that's where a multi-line comment is important. And again, just like this one, the compiler is going to hit this symbol here and say, okay, ignore everything until we get to this close comment symbol here. Okay, so it's really good to always write comments in your code so that people know what you're doing. Because sometimes just reading the code, you might not understand what's happening. All right. The other little concept that we're going to throw in here is white space. So white space is anything that's not a character, printable character. So an actual space, like hit the space bar, that's white space. A tab, that's a white space. A return at the end of a line, that's a white space. And those are not compiled. Generally, they're not significant to the compiler. What they do allow you to do, though, is space out your program so it's easier to read. You absolutely can write code that's all crunched together. The compiler doesn't care. They said that's fine. But as a human being, I look at this big block of code and my eyes hurt. It's like I don't want to read that. And so if you use the white space to space out your programs with some spacing in the middle, it's a lot easier to read. Okay. Now, let's talk a little bit about errors. Because we're human and we make mistakes, you're going to run into 3 kinds of errors when you're writing your code. So let's talk about them. The first is a compile time error. And this is where you might say, you have a line of code, let's say, string s is equal to hi. Okay, well, don't worry if this doesn't mean anything to you quite yet. But here we're creating a string hi and assigning to this variable s. There's an error here. Now you don't know there's an error, but I'm going to tell you there's an error. In Java, you're supposed to end each line with a semicolon to tell it, hey, this is the end of this line. But if you forget that, the compiler is going to go, hey, I don't understand. I was expecting something. And as it continues to try to compile the program, it's going to say, hey, wait a minute, stop, I'm confused. And it will give you a compile time error. Okay. So that's a compile error. Okay. The next kind of error you're going to see is a logical error. And a logical error, and it's kind of hard for me to think of an example right now, but they're the hardest to find, to debug, because what a logical error means is your program was correct, it compiled just fine, and it ran just fine. Nothing went wrong, it just didn't do what you told it to. The result you expected didn't happen. And what a logical error really means, remember I told you in the beginning that programming is a sequential set of steps. You told it to do the wrong thing. It did exactly what you told it to. You just told it to do the wrong thing, and you don't know that you told it to do the wrong thing. So you have to go in and figure out, well, what did I think about wrong? Maybe I multiplied when I should have added or something. But you told it the wrong thing, and it did it, and you didn't get the answer you wanted. So that's a logical error. And then there's something called a runtime error. And a runtime error can happen in a number of cases. Let's say you did something that went through the compiler, but technically impossible, like you divided by 0 in a math equation. You can't do that, so it would explode. Or let's say later on in more advanced programming, you tried to talk to a database, but that database was down for some reason. That's a runtime error, because it's only when you run the program you figure that out. Or you ask for user input, and they gave you something crazy that you didn't expect, and your software failed. That's a runtime error. There's no problem compiling. There's not necessarily anything wrong with the logic, just that user gave you the wrong input. So these are the 3 kinds of errors that you're going to see while you're coding. These are my favorite, because you got this piece of software called the compiler that finds all those errors for you. It tells you, hey, you screwed up, fix this. And so immediately you know how to do it. These are the worst kind, like I told you. It's hard to figure out, well, what did it, I meant this, but why isn't it doing what I meant? Okay. All right. Let's talk a little bit about input and output. This thing doesn't erase so well. Okay, I'm going to show you how you output something in Java, and it may not make complete sense to you right now, and that's okay, but you can use it anyway. System.out.print. Okay, so notice a few things about this statement. There's a semicolon at the end. A string, whatever you're going to print out, is got double quotes around it. And here's this print, which is what we want to do. Now, what's all this system out in front of it? Don't worry about that, just do it. Java needs it. Some other programming languages have ways of doing this. You don't need all this ceremony, but in Java you do. Okay. And they also have same thing, dot print ln. Okay, so what's the difference between, other than an ln, what's the difference here? The ln version of this is going to have a return at the end of the line when it prints it out. The just regular print one will just say hi, and the output will stay right there. So if you print something else right after this, it'll be on the same line. So a little convenience. Now, printing things out can be a little interesting. Remember I said you have these double quotes. Well, what if I want a return in the middle of your string? Well, there are ways to do that. Let's look at a few. There's a few isms when you're working with strings. It's completely erased so we don't confuse people. Okay, so we won't do the system out println thing. You can just assume that. I'm just going to focus on the string inside. So if I said hello /n world in quotes, that /n is basically going to tell the computer hit a new line when you're there. So it'll do this, hello world, when you run it. Okay. Or what if you wanted to put quotations? You wanted to put quotations around world. Let's say your name is Mike, and I wanted, but the output that I want is hello Mike, with Mike in quotations. So you think, okay, if if I just say hello, Mike, that should work, right? No. If you need double quotes inside the string, you have to have a slash in front of it, just like the slash n. The slash is what they call an escape character. It tells the computer, hey, something special is happening. In this case, we're printing, or we've got a quotation character inside the string. Okay? Or likewise, what if I want a backslash in my string? Same thing, you'd say slash slash. And so that would print out hello slash Mike. Okay. So some weirdness there when you want to print things out in the middle of the strings, but it kind of makes sense if you think about it. Okay, let's see. All right, variables and assignment. Let's talk about that briefly. If we had to specify everything with quotes, programs would be pretty stuck and it wouldn't be very meaningful. So we want to be able to have variables, a place to store information. In fact, actually, before we get to that concept, I'm going to change up the order from the book here. I'm going to talk about data types first. Data types are a concept in computer science where you classify the kind of information you're working with. Okay, and we're going to start with 4 basic data types. In fact, they're called primitive data types because they're like the most simple, basic ones there. Int, double, Boolean, and char. Okay? Now the reason we have data types is as the computer is running, it knows how to behave based on the type of data you're dealing with. For example, if you have an integer is just a simple number with no decimal point, like 5 or 29 or -3. You know, if you add 2 integers together, like let's do this, you know, 1, 2, 3 plus 1, that equals 4, right? But you know, I don't have string on here. We're going to talk about strings later. But if I had 1, 2, 3 as a string plus 1 as a string, that does not equal 4. That equals a string of 1, 2, 3, 4. See, so both of these are using plus, but they behave differently because of the data type. That's why data types are important. So an integer, like I said, is just a counting number. And a double is something that has a decimal point in it, like pi, right? 3.14 dot blah, 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 blah. And you think, well, why do we need 2 different data types to talk about numbers? Why don't we just say number? Good question. The reason is because it's more complicated both for humans and for the computer to handle the decimal point numbers, the doubles. It's computationally more complex to do operations on a double. So if you know you have data that's an int, like somebody's age, and it, you don't go around talking about somebody, oh, I'm 15.3 years old. You know, technically you could be, but that's not how we do it. We just say you're 15, right? Then just use an int. It's a lot easier. It's faster. It's cheaper. It's easier to understand as a human. It's easier for the computer to understand as well. But if you're doing like, give me the circumference of the Earth. Well, that's a really huge, complicated number with a lot of scientific precision. You'd use a double. An int probably you'd lose a lot of that fidelity, that accuracy. Okay. So that's why you have 2 number types here. There's actually more, but for your test here, we're gonna just focus on int and double. Boolean, that one's easy. True, false. That's it. That literally is binary, 0, 1, true, false. And a character is a single printable character, like that. And the difference between a character and a string, a character is only 1, just 1, and it's a single quote. Okay, so single quote, not double. If it was double, it's a string. Don't get confused there. But a single quote is just 1 single printable character. It could be a number, Could be a special character like an @ sign or an underline, something like that, or letter of the alphabet, capital, lowercase, things like those. It could be other characters too, like Unicode. Don't worry about that. But and it's one character. That's the important thing. So those are your 4 primitive data types that we're going to worry about here for this course and the review for the exam. Make sense? Too fast? Yes.
What does the 1, 2, 3 plus 1 equals 4 mean?
Here
Yeah.
or here?
Both.
Okay, good question. The question was, well, you heard the question. So the reason I highlighted this is to illustrate that data types are important because it tells the computer how to behave with the information. Okay, so in other words, these are ints up here. 1, 2, 3 is an int, 1 is an int, and you can't mix them up. You can't say, "I'll take a string and mix it up with an int." It all has to be the same. So I'm saying this is an int, this is an int. So this plus, when I say 1, 2, 3 plus 1, that's a normal mathematical addition. So 1, 2, 3 plus 1 is equal to, I'm sorry, that's not even right, is it? I made a mistake. 1, 2, 4.
Okay, yeah.
There you go. Is that what was confusing you?
Basically.
Okay, yeah, so that's 1, 2, 4. It just did a mathematical addition. But when you're talking about strings, 1, 2, 3 in a string and a 1 in a string, and you put a plus there, it just tacks the 1 to the end. 1, 2, 3, 4.
Why 4 not?
Hmm?
Why 4 and not 1?
I made 2 mistakes. You're completely right.
David caught it first and then he told me about it.
Just remember what you're paying for this class. Nothing. There you go. It's 1, 2, 3, 1. All right. Good catch, guys, really. So arithmetic combination, string is called string concatenation. Just adding 1 to the end of the string. Point being, I don't want you to get wound up in this. Point being is different data types behave differently. The frustrating part for somebody learning this is if I was to print out this part, I was to use that print line and I printed out 1, 2, 3 and 1, 2, 3 as a string, it would look the same on the console. It would print out 1, 2, 3. And so there's a temptation, oh, it's the same thing. No, it's not. They're actually totally different data types and they'll behave differently as you use them. Okay? All right. Let's see. Okay, now we can talk. Now we talk about data types. We can talk about variables now, because variables all have a type. So a variable, think of a variable as just a little box of memory in the computer that you're going to put a value in. You're going to give that box a name, so that it's easy to remember later on. That's all a variable is. So I can think of, well, we've talked about this already. Int age equal to 16. That's what they call the assignment statement. That equals there is assigning. It's assigning the value 16 to this variable age. So there's a little box in memory. We're going to call it age, and it's an integer. So to declare a variable, you start with the type, the name, and then you assign it to something. Now later in your program, I can change that. I can say age is equal to 17. I don't have to put the int in front of it because it's already defined. The computer already knows what age is. I only have to do that the first time. Later in the program, you could just give age a different value. Now, why is that handy? Well, because most of the time, actually, when we run a program, we don't actually know what these values are. Maybe we get them from the user, maybe we read them from a web page or from a database or somewhere else. That's what makes programs so wonderful and flexible, is you can run operations on data that we don't even know yet. You have to know what you're getting, right? And so you define these variables and you can assign the values later. And then you operate on the values in these variables. So what can you do with these variables? Well, let's look at some arithmetic. I think these are called arithmetic operators. Yes, arithmetic operations. So simple ones, we'll just stay with age for now, okay? Just because that's easy to understand. You know, you can say int next year age is equal to age plus 1. I've defined age up here somewhere. Okay. So what I've done is just simple math. This variable age, whatever it is, don't know, don't care. Somebody else has already assigned that. Age plus 1, and that's next year age. Okay, so that's pretty simple. Now, I want to call out something real quick before we go ahead, and that's the label I gave this, the name. I made it clear. I didn't just call it A or X. Okay, I gave it a clear name, and there's no spaces. You can't put spaces in the label. It could be, you can have an underscore, but it must be letters and numbers. It has to start with a letter. And in Java, there's a convention. It's actually called camel case. It's not in your book, but the way that works is the first letter is lowercase, and every you smash the words together, and every subsequent word starts with a capital. Makes it really easy to read, and if you're working with other Java programmers, they'll immediately know what you're talking about. Okay, so this is just plus 1, and of course you could have last year age and have a minus. So I know this is shocking. Your math operators are plus, minus, times, divide, and modulus, which is the remainder. So that's it. Ta-da! All of those will work on your number types, so your doubles or your ints. Okay. Now there is a little bit to discuss. Your book doesn't go into this. The book doesn't go into this, but I should mention it briefly about precedence, operator precedence, like plus. Okay, which happens first? So if I say, let me see, so we can come up with a good example. 5 minus 3 times 2, right? Okay, that's a pretty good example. So what's the answer to that?
Huh?
What's the answer to that problem?
-1.
Yes, it's -1. Now, how did you get there? Well, you did the times first. You didn't say 5 minus 3. You didn't just go left to right. 5 minus 3 is 2, times 2 is 4. No, we said, no, we're going to do the times first. Why? That's called operator precedence. Some things you do first, and then you do others. So times, and it takes precedence over minus. Now, what if I actually meant left to right? Well, then you could force the precedence with parentheses. So 5 minus 3 times 2, that way is actually 2. I'm sorry, 4. Math is not my thing today. Okay, because now I've done this first, because I forced the issue with the parentheses. That same thing works with variables. So if you've got a formula and you don't actually have these actual numbers, you're just using variables, you can still use parentheses and the math operators to force the kind of computation that you actually want. Okay. All right, a couple other little tricks, and then I think we're closing in on the end of this chapter. Java has some convenient shortcuts for some of these. Like if I want to say, okay, like say int age is equal to 15, okay, and I want to increment that, I could say age is equal to age plus 1, right? I can do that. Works. Nothing wrong with that. I can also, in Java, do this. Age plus plus. That's just a quick increment that adds 1. Age minus minus, decrement, minus 1. Okay. Now what if I have age, let's see what we go with age, int, I don't know, factor. Let's say I'm computing some sort of a score for a game or something, I don't know. All right. So I have two ints and I want to combine them somehow. And I want to say something like age is equal to age plus factor. Okay. Okay, again, that works, no problem. But I can also do in Java age plus equals factor. Shortcut means the same exact thing. So unsurprisingly, there's shortcuts for plus equals, minus equals, divided equals, multiply equals, and modulus equals. It's just a shortcut. Use them or not. But okay, so I think we've covered all this material in this chapter 3. One last thing, casting. I'm glad I saved it for last because it's real, but it can be abused. Casting is where you take a data type, remember the 4 data types, and you basically force the compiler to view that data as something else. So let's say I want to say int score is equal to, it's probably not a great example, let's just say age, times 15 for some reason. Okay, now actually let's do this. I want this to be a double. So maybe I'm going to do something fancy with it later. Now the problem is that's an int, it's going to produce an int. It wants a double. And so it's sometimes handy to be able to force the compiler to view one data type as another. So the way you would do that is with like this. You put this in parentheses, age plus factor. What did I say? Plus whatever it was, 3. I don't care. Whatever it was. But you see, I basically forced age, which was an int, to now be viewed as a double, and added to 3 and assigned that double to score. Okay. This is handy, but I will warn you that this can be easily abused and cause you runtime errors when your program fails because you were too aggressive in your cast. You cast something you shouldn't have. Like let's say you would cast age to I don't even know if the compiler would let you cast it to a Boolean or something, but even in this case where you cast it to a double, it may wind up not doing what you expect. So be careful with this one, this casting. So with that, we have covered the first module. You're 10% done with the review for the AP Computer Science course. Thank you.